Area of a trapezoid. The first thing to be able to calculate the area is to be able to recognize a trapezoid. So these three figures are all trapezoids. The top one here is our most common looking one. What identifies a trapezoid as a trapezoid is its two parallel sides. So any trapezoid that you look at, you have to be able to find its two parallel sides. These ones are going vertical this time, and now another horizontal one, but what we call the legs are now going in. This one has a 90-degree leg that's attached to a parallel side, and then a slanted one, and the two legs here. If we were to chop this one up like we've been doing our composite figures, we would look at this and we would say we have two triangles and a rectangle. Rather than calculating those three areas separately and adding them together, we can create one formula for this figure. Knowing that there's triangles in there and we have a base times height divided by 2, we can predict that the area of a trapezoid is going to have that divide by 2. So if we look at this as our height, our height here, and same if it was here, this would be our height, and this one here, our height would go this way. The two parallel sides are what we're going to label as base 1 and base 2. It doesn't matter which one's 1, which one's 2, as long as they're both the parallel sides. So now we have our rectangle in the middle, we have our two bases, and our height. Our formula is base 1 plus base 2. You have to do that step first before anything else. We multiply by its height, and there's our divide by 2. So if we give numbers to this trapezoid, we have a height, let's say, of 5. This base will be 3, and this base will be 7. We can go, starting with our formula, area equals base 1 plus base 2 times height divided by 2. So base 1 is 3 plus base 2 plus the base 2 is 7. Our height is 5. And all of this divided by 2. 3 plus 7 is 10, times 5, all divided by 2. Try to get in the habit of keeping your form and keeping all the steps as you progress down. 50 divided by 2. So our area of this trapezoid is 25, and let's say it was meters squared. All those numbers that I've given here would be given in the question. They're not things that you have to create. If we were to now check our answer, let's say using our composite figures, we would have our area of a rectangle is length times width. So our rectangle is here. So we have 3 times 5, 15 meters squared. And then the area of the triangles. Now here we would be assuming that in this trapezoid that this piece and this piece are equal. So it'd be an equilateral triangle. It would not work in all of the cases. So we would take this whole length here, and let's just show what that would look like in yellow. So if we were to mimic that length there and subtract it from the short length, it will give us those two leftover pieces. So we have 7 subtract 3 is 4. So this piece here and this piece here both add up to 4. So both of them are each going to be 2. Okay. Area is base times height divided by 2. Our base is 2. Our height is 5. All divided by 2. 5 times 2 is 10. Divided by 2 is our 5 meters squared. Now we have to remember there's 2 triangles here. So this would be 15 plus 5 plus 5 give us the 25 meters squared, which is the same answer that our formula got us. So again, the tricky part is 1, finding the parallel sides, knowing that that's going to be your base 1 and base 2, and then finding the height and plugging it in. Once you have those 2 parallel sides, we can do it that way. You can always do your check by subtracting your short and long line and making it a composite figure of a triangle and a rectangle, or two triangles and a rectangle.